We recently received exciting images from the James Webb Space Telescope, JWST, that point to where it all began. This discovery challenges our understanding and piques the interest of astronomers and scientists alike. This suggests a potentially colossal event that could change the universe as we know it, raising concerns about the foundations of our cosmic existence. Could this discovery complete everything we know? Is the universe on the brink of a transformative event beyond our current understanding? Join us as we explore the latest discovery from the James Webb Telescope and how it could transform the universe. When we look at the edge of the universe, we start at the observed universe. It's like looking through a window into space. The observable universe contains everything that we can now observe, measure, and study with our telescopes and space missions. It is the collection of stars, galaxies, and celestial bodies visible to us. However, the observable universe is only a part of the whole cosmos, a small piece of the vast cosmic pie that humans can study and understand. The size and shape of the universe is still a mystery. The diameter of the observable universe is about 93 billion light-years. This number is due to several factors, including the distance that light can travel in one Earth year, 9.46 trillion kilometers, or 5.88 trillion miles. A light-year is the distance that light, the fastest in the universe, travels in 1 year. The estimated age of the universe after the Big Bang is 13.8 billion years. This means that the light emitted by objects in space that humans can see traveled to Earth for a maximum of 13.8 billion years. This means that the observable universe is 13.8 billion light-years away from Earth in all directions, or 27.6 billion light-years in diameter. However, Hubble's law says that space has expanded since the Big Bang, and thus the observable universe has also expanded. Estimates of that expansion show that objects emitting light 13.8 billion light-years ago are now even farther from Earth, about 46 billion light-years away. This shows that the observable universe extends more than 46 billion light-years in all directions from Earth and is about 93 billion light-years in diameter. Therefore, when we say that the observable universe is 93 billion light-years in diameter, we are talking about an immeasurable extent. About 13.8 billion years ago, a massive explosion began, the Big Bang, which we now call the cosmic expansion. Since that historical moment, the universe has not only expanded, but also accelerated. This acceleration appears to be driven by mysterious forces such as mysterious dark energy, pushing the boundaries of the universe further and further apart. Matter began to form under the influence of gravity as the cosmos expanded. This gravitational pull forced the particles together, resulting in amazing structures like stars, galaxies, and eventually planets like our own beloved Earth. Because the universe is constantly expanding, the observable cosmos grows by another light-year every Earth year. Meanwhile, light from distant objects reaches Earth for the first time. This means that people will see more and more space over time. Although humans will never be able to view the entire cosmos from Earth, the field of view is constantly expanding. Technologies that stop and process electromagnetic radiation outside the visible spectrum allow people to find and view distant individual galaxies, clusters, and superclusters in the observable universe. Special telescopes such as radio telescopes, X-ray telescopes, ultraviolet telescopes, infrared telescopes, and others are useful in this regard. The famous Hubble Space Telescope and the James Webb Space Telescope made it possible to visualize the first stars and galaxies born in the visible universe, making these wonders more accessible to the public. Despite its vastness, the universe is strangely empty. Even if we shrunk our entire solar system to a quarter of the size, the nearest star would still be about 2 football fields away. This magnificence extends only to our own Milky Way galaxy, one of billions in the observable universe, and gives us a sense of cosmic grandeur. You might wonder why we can't see everything in space. There are several reasons for this limitation. For starters, even though light is the fastest object in the universe, it still takes time to travel through space. This means that when we look at distant objects, we are essentially looking back in time. The more distant the object, the longer its light has to reach us. It's like looking through a cosmic time machine and revealing the history of our universe as we see galaxies millions, if not billions, of light years away. However, there is another component at work here. Space expands. Consider the surface of an inflated balloon covered with dots. The dots move further apart as the balloon grows. Cosmos follows the same principle. Galaxies drift away as the cosmic fabric expands. The light emitted by distant objects undergoes a transformation known as redshift due to this expansion. The wavelengths of light are stretched as objects move further towards longer wavelengths, which are usually seen as a reddish hue. Some celestial bodies eventually pass a crucial distance, known as the cosmic horizon, where their light is too far away to reach us due to the expanding nature of the universe. Considering these two main factors, the time it takes for light to travel and the expansion of space, it is not surprising that we have not yet seen the whole universe. Even with the latest telescopes and technology, our views are still limited by the basics of the universe. Let's explore these concepts in a little more detail. The size of the universe is amazing. Scientists use measurements such as light years to show the distance light travels in a year. That's about 5.88 trillion miles, or 9.46 trillion kilometers. Our galaxy, the Milky Way, is about 100,000 light-years across. Even in our galaxy, the nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. When we look into space, we see galaxies billions of light-years away. This means that the light we see from these galaxies began its journey billions of years ago, giving us a glimpse into the early history of the universe. The mystery of the edge of the universe and the search to understand the possible edge or limits of the universe has attracted the attention of many individuals from various fields. Although we still elude clear solutions, three important ideas have been developed, each providing a unique insight into the vastness of outer space. The first theory claims that the cosmos is eternally long, with no apparent end. This idea is consistent with the cosmological principle, which expresses the isotropy of the universe, its uniformity and appearance from all sides. If this concept is true, it means that space has no boundaries and can spread forever in all directions. Another theory offers an alternative perspective, arguing that while the cosmos may be finite, it has no clear edge. Instead, it is compared to a massive spherical or curved space comparable to the Earth. In this scenario, if someone were to travel in any direction indefinitely, they would eventually return to their starting point, just like the rest of the world. A third theory, the multiverse concept, offers the fascinating idea that our world is just one of many. Think of many worlds, each with its own physical rules, constants, and attributes.
These universes can be completely different and operate independently of each other. Alternatively, they can be linked by complex systems to create a large and complex multiverse. The study of these theories has both scientific and philosophical interest. The concept of infinite space challenges our perception of space and our understanding of its vastness. On the other hand, a limitless universe without edges challenges our notions of limits and continuity, offering the potential for cyclical patterns of spatial patterning. The theory of the multiverse with its parallel worlds offers a rich environment for research that shows that there are dimensions completely different from our own. If true, it could mean that changes in physical laws and fundamental constants could give rise to entirely new forms of existence, opening up a world of possibilities beyond our current understanding. However, these concepts are theoretical and difficult to understand. Exploring the edge of the universe involves enormous obstacles. These theories are difficult to confirm or definitively disprove due to the vastness of outer space and the limitations of our available observational instruments and technology. Finding the edge of the universe was an exciting adventure full of theories and ideas. However, one game-changing tool, the James Webb Space Telescope, JWST, stands out as a beacon of hope, shedding light on the mysteries of cosmic origins. This unique tool has the unparalleled potential to reveal the mysterious history of our universe, allowing us to gain knowledge far greater than previously imagined. JWST is an engineering marvel specially designed to observe the universe with unprecedented precision. Its amazing properties allow us to see the beginning of the cosmos. JWST discovered massive galaxies dating from 500 to 700 million years after the Big Bang. According to a recent study published in the journal Nature, these ancient galaxies defy predictions with diameters significantly larger than their age. These surprising findings challenge accepted theories about the origin and evolution of galaxies in the early cosmos. Astronomers initially expected to see small nascent galaxies during telescope observations. Instead, they were surprised to discover these giant cosmic beings that changed the story of galactic evolution. The maturity of these old galaxies is simply amazing. Contrary to popular belief, these cosmic giants have reached the same level of development as our 13-billion-year-old Milky Way. According to Dr. Lear, lead author of the study, this discovery defies our understanding and opens the door to a new perspective on the evolution of galaxies in the early history of the universe.